The Internet of Things connects devices together to improve the quality of life, society and industry. Connected healthcare is in fact the sleeping giant of IoT applications. And in this course, Colin Dobbyne from Big Blue Solutions explains why SDVoE technology is the perfect solution for bringing the Internet of Things into the operating room.
So I didn't introduce myself. I've been involved in operating room control systems for a long time, designing all kinds of systems for all kinds of companies, for a long period of time my own, and I've installed systems all around the world and listened to many user needs, so I think I have a good understanding of what I'm talking about, maybe not. I'm also an SDVoE design partner, and one of the most interesting trends currently is the move of video distribution from a matrix-based system to IP. You see a lot of IP video, and this is my talk is really why you should do that. But before we get going, there's going to be one lucky winner is going to get £20, I think it is, maybe $20, maybe £20, if you stay the course. And the really, really lucky winners, if you put your business card into the bucket coming around, you'll get a copy of my book, which is how I use video over internet to set up a teaching link in East Africa to enable the teaching of keyhole surgery. So keyhole surgery has been going in Tanzania now for about 8 years, and it's a direct result of the surgeons in the UK being able to coach the surgeons in Kilimanjaro. And this book is a sort of a look at that and the life and times of by that journey, which was a wonderful experience. So hopefully you would be interested in that by putting your card into a bucket. So I think that's all the introductions taken care of. So the question is, why use SDVoE in the operating room? And there was a clicker here yesterday. Here it is. So just to, before we get into why use video over IP, let's just talk about IP. The whole world is moving to IP, one form or another, Ethernet, Wi-Fi, satellite, but it all comes down to IP protocols, IP communications. And it didn't just start, it wasn't just born as an international standard that we all kind of jumped on board. It started off as a proprietary system. It was invented by an engineer at Xerox in Xerox PARC. A lot of the modern day innovations, the mouse, the tablet, all of these things were from Xerox too, but the TCP IP was only in Xerox PARC and nowhere else. Then one of their engineers left and set up 3Com, but then 3Com devices couldn't talk to anything, so new startups said, oh, well, let's go on with the TCP IP, that's pretty cool. And so more devices, more companies, and that's the de facto standard. It is a de facto standard. It didn't start off as an international standard, it's just de facto. And what's interesting is in less than 30 years, so from when IP first started, when it was born, we had the first cash machines, one of the first global uses of that, connecting the world of our life to money. Then the mobile phone companies, they wanted to get involved, so for data they invented 2G, which wouldn't even operate now. You couldn't even use that. The first video phones were launched, all in 1990. We started to send text messages instead of making phone calls, so we were sending messages over IP rather than making the phone calls. And a very brilliant Englishman, Tim Berners-Lee, working for CERN in Switzerland, he invented the first web browser, and that's who we have to thank for the World Wide Web as we know it today. And that has connected all the physical worlds that we know of. And what's also interesting is the increasing growth rates of connected devices. So in 2025, it's predicted there will be 80 billion devices connected worldwide. And you can see we are even at an inflection point. So to think about, is there still room for something else? I think it's pretty well done that IP is here to stay. And it's working, right? Okay. So then in that context, there's lots of things we can do with IP, and one of them is distribute video. And currently in the operating room, so the rest of this talk is pretty much focused on the operating room. There's two ways of connecting devices, so cameras to displays, televisions, speakers, microphones, things like that. And one is the most common up until very recently, last few years, the matrix method, the matrix control system. So we have Karl Storz, I think, went up to 32 by 32 inputs and outputs. I think Stryker were 18 by 18 on a video matrix. So they're all around there with a professional video matrix, 12G SDI, HDMI, and now there's another option you would have would be HD base T to make use of Cat5 cable, for example. But these are all proprietary, they're all closed systems, they are just for the purpose of distributing video. HD base T, of course, has the 5-play, which will allow some internet, some IP connectivity. But nevertheless, it's a star network, star topology, and if you are connected to the outside world, it's through the controlling device as a gateway, okay, because it has to be translated through that proprietary system. So overlaying the video would be control of the devices, and that would also be proprietary. The other way of looking at it, the other way of designing a network would be to not centralize it, so decentralize it. So that's what the modern internet world looks like. It's lots and lots of clusters, decentralized. And then you can have fully distributed, where it's like a mesh topology, where there's just a load of nodes all interconnected. And that's the modern way of system architecture, because there's no single point of failure. So that's the standard network topology. And my talk is really about how we can exploit that. So if we were to say, well, we want to stay in the matrix world, can we get connected to the Internet of Things? Can we become part of the global community of other physical worlds? And of course you can. You could use something like HD base T, like I said, which has the 5-play. It's great delivery of video. It does have the ability to transport other control codes and IP-based information. But the controller, the system controller, must manage all that traffic, because outside of the room it doesn't understand HD base T. So it must control and convert all of that information. The controller then becomes a single point of failure, and then all devices must support 5-play, but not all devices do, because it's not mandatory to support 5-play. You can pick and choose from HD base T how many of the 5-play you want to. So you're at the mercy of what those manufacturers have built into that system. But it is a good matrix-based system. Another way of doing it is you can add a data switch to your system design. So you can do your video distribution in matrix, and you can overlay an IP switch to pick up the information from those attached devices. But then you have to add a 10 gig Ethernet backbone if you want to transfer video, or 1 gig if it's just for data. So you've got a switch and a matrix in the same system. So your costs go up because you have to have a matrix and a switch, and your system complexity will increase, and you have to run at least 2 cables to each device. Okay? So if you're adding a data switch, my question is, if you are going to add a data switch to your system design, why not use it for all of the traffic? Because you can with SDVoE. So let's explore why we do want to have that data enrichment of an OR system. So here we go, just to finish the point on SDVoE, rather than a single point of failure, with SDVoE there are multiple independent communications. So for example, locally there could be a local help desk, patient records, of course, DICOM server for patient images, the PACS. They're all based on the Ethernet, and there could be an issue in the OR, and the local help desk can run a remote desktop session and control the controller to help the circulating nurse or staff nurse just with a user error, user problem. Okay, that can be running whilst the video is all being transmitted through the switch. At the same time, there could be a software upload from the manufacturer, a bug fix or a procedure-specific piece of software, which is temporary for that procedure and then gets replaced later on. So there's lots and lots of multiple communications simultaneously by having a switch in your design. And there's no additional cabling required because you've got a switch and everything's connected with Cat5 cable, so you get IoT for free. So why is IoT important? Why should we build it around a switch? Why should we enable data? Why should we data enrich our operating room? So I was looking for various definitions of IoT. What does it actually mean? This is the one I like. It might not be your favorite, but I like this one. IoT devices are connecting different physical worlds together to improve the quality of life, society, and industry. Okay, all good things. It also invades your privacy and everything else, but never. That's the downside. But these are the good parts of it. Okay. So what about healthcare? Why do we not have this same connectivity in healthcare? So if we just look at the rest of the world, I mean, just around here, you can go to Control 4 and look at all the smartphones, Zigbee and all that stuff for your smart homes. And all of these worlds are connected. They're all sharing the same data, or some of it. Okay, so let's say I did see a stand. I've no idea why they're here, but there's a weather station stand around here somewhere, but it's quite interesting. But yeah, weather stations, okay, very important, especially in Florida. You can see behind the golf desk there's a screen with all the weather, rain coming in and everything. But that's used to control irrigation, to save water. But that information is also shared with the golf club, because they may have to close the course because it's a thunderstorm, electrical storm. Now, the smart thing then is to take that. The course is now closed. I learned a new thing in the USA, CTO, car towpath only, or something like that. So getting everybody off the course. But what if the golfers are on their way? So why not send a message to the home before they've left home, or to their car if they're in the car on the way, or if they're doing something else like a shopping centre on the wearable to say course is closed. Then maybe the travel apps can give you a route around any flooding. Smart cities and retailers can say come shopping instead. You're in the dry, we've got shopping malls. So all of this world is just from that information of a weather pattern coming in. That information is useful to us. It improves our lives. We can do something else. Not turn up at the golf course to say, oh, it's shut. Just one silly example. Okay, so that's why these worlds are being connected. It enriches our lives. But what about healthcare? So this one really resonated with me. Connected healthcare remains the sleeping giant of the Internet of Things applications. Okay, so we saw how all the other physical worlds are being connected and using that data, but why not in the operating room? This slide I've been using for about 20 years, this particular photograph, because I was in my company previously was transmitting live surgery to lecture theatres so that you didn't have to have 100 people sitting in the room. But this is the state of some bold statements here, but they're pretty much 90% bang on. There is no open standard for interoperability with other manufacturer systems. So the major endoscopic companies or the lighting companies or the table companies, they have their protocol to control their devices, and you can't mix and match. Only 5% of endoscopy imaging systems in the UK are actually connected to the network at all. They're just frame grabbers, effectively. Of course, consequently, there's no inclusion of artificial intelligence or augmented reality or any kind of image processing in assisting decision making. There's very little data acquisition of the health and usage of surgical equipment. They use it till it breaks, and then it's the medical physics department's problem. There's no preventative maintenance. On-site servicing is normal. It's all on-site, book and engineering. Very little remote service. Most endoscopy is performed with a shared mobile cart. C-arms, ultrasounds, patient monitoring are standalone systems. Yes, you can share the image, but that's about as far as it goes. So all that invaluable data about what were the settings, what was the data inside the machines, what were the instruments that were being used, what was the pulse rate, the core temperature, all of that information that could be fed back to improve surgery in the future, to say, if you use a 30-degree scope, you get a 10% improvement in patient outcome. You can only do that if you've got data to back it up. But this is all empirical right now. The clinical directors sit around and say, I think this, I think that. There's no evidence. So the data is being lost. And 100 years ago in a Victorian theatre, to gather information about a procedure 100 years ago, you had to physically be present and take notes. That's why in the UK they're called operating theatres. And for me, not much has changed. So what about the future? What would the future look like? What would the IoT operating room look like, and should it be connected? So this is where we are now, pretty much. You have a number of video sources: camera, C-arm, ultrasound, endoscope. That's the normal. Camera could be the in-light camera, room camera. And then you have a number of displays, 2 surgical displays, maybe a big flat panel on the wall. And you have a human interface. And this is centered around a human interface touch panel normally, video touch panel. So you just press a few buttons and you do your routing. And that's controlled by a machine, which is called your man-machine interface controller and the routing controller. And that's every system for the last 20-odd years, right? Pretty much. We have seen enhancements to that. We can add a capture. So we can actually take some photographs of the procedure. Other companies have done device control, so they control the operating room lights, they can control the positioning of the table, all from the same human interface. And these closed systems tend to be based on proprietary controls. So every manufacturer, every company has their own bus for communication. So interoperability is not possible. But what happens then, they want to break out of the room, so we add some audio and we add some comms. And then to break out of the theatre, these proprietary systems need to bridge to IP. Outside the OR, they have to be IP. Okay? And so this is the first step into the IP world, and that's for sharing. So there will be video streaming over the network in low bandwidth, high latency, high compression, but good enough for surgical training by video. But we can start to add more land-based services by passing data through the proprietary man-machine gateway. So we can do setups, we can do surgical preferences, surgeon preferences, we can do procedure-specific software, for example. We can maybe go online and see if our professor is online, and so we can only do that if we start having IP-based services. But we're still squeezing everything through that matrix-based controller if we are matrix, but not if we are IP switch-based. If we even go bigger data, we can add more and more services. If we start thinking big data, like having timers, counters, a black box to record everything that went on, to use analytics for performance and feedback. So we're following that curve of more and more devices connected, more and more data being collected, more and more data being processed. Are we still going to squeeze it through a matrix controller, or are we going to go IP in the OR? Now bring in more worlds, like the chart of the physical worlds I had. What about finance? One example, finance. They want to protect themselves from liability, malpractice suits, things like that. They want to record everything. They want to know what consumables were used, what instrument was used. They want to be able to audit the tracking of the surgical instruments and the trace to make sure that there's no CJD infection or something like that. They want to see efficiency and productivity drives. Maybe they want to sell that data back to the manufacturer and say, here's some real good data to help you make a better product. Now you have a feedback loop for performance improvement. So we can push that back in, and then we can start doing heads-up display for something we've processed outside. We can do predictive commands. We can do some virtual reality, artificial intelligence, augmented reality, whatever you want. So we are improving the performance and the environment of the workplace of a surgical operating room. So thank you for that. My take-homes then of why use SDVoE, it's got nothing to do with the quality of video from point A to point B. There are loads of ways of doing that, okay? But SDVoE is as good as any of them. The video quality, the latency, it's effectively uncompressed, and it's sub-frame latency, the same as all the professional broadcast formats, the same as everything else there. So it's not about video, it's about everything else it opens up for you. That's why you should use SDVoE as your video distribution in the OR. Put a switch in there, and a big one. So, to bring IoT to the OR, you need a data switch. So why not distribute your video with the same switch? Why use proprietary systems that keep the data on the dark side? The cost of a matrix increases with advances in technology. A 4K matrix is more expensive than a standard definition one. It gets harder and harder and harder to do. The cost of IT switches is continuously falling. For $1,000 you can get a 48 port 10 gig switch. Okay. SDVoE provides the same or better quality video as proprietary formats. The other take-home, second take-home, all data and signals are now accessible to interoperate with other systems. We are able to connect to other physical worlds. There's transparency, cybersecurity, archiving opportunities, network-attached storages, cloud-based technologies. With SDVoE, video devices are connected to a global communication standard. Okay, TCP/IP, or the Ethernet, or the Internet, whatever you want to call it, that is a global standard. It allows multiple paths of independent device access. You know, just like the Internet, there's millions and millions of transactions going on simultaneously. You can increase the potential for other system actors, like bring your own device. Just point a web browser at the control interface, and there you go. It's based on IP technology. It allows for automation, because other systems out there will have an Internet Protocol interface. It will also facilitate redundant or remote independent controllers for assistance. So the only device that a medical physics guy has in his room, in his office, is a device connected to the hospital network. So only by using the hospital network can he go to the OR without physically going there. He can log in over the IP into the controller, fix the problem. To run a redundant system is a $100 Raspberry Pi. You can actually have an emergency system backing up the main controller with a simple GUI to do the switching for you for emergencies. It costs you $50 or $100 for Raspberry Pi. The main point about the data enrichment, what I see is the vital missing thing is, like, you know, in aviation, every crash is an opportunity to learn. Okay, that's the whole ethos of the FAA, the investigation team, is how do we prevent this happening again? And they can only do that with data. That's why it's illegal to tamper with the black box. Okay, and that's why it has beacons and everything else. They have to get that. Okay, every accident is an opportunity to learn. In surgery, unfortunately, that's not true. Okay, because they will have a debrief, they will have a session to find out what went wrong, but there's no data to support any of the findings, or very little data. It's one word against another often. In London, famously, every year there's cases where the surgeon said this, the circulating nurse said that. If you had data, could prove, if you had even just a low bitrate video stream of the whole procedure, you could prove, you could put the argument to bed. This is what happened. So, it's turning data into insights. Operating costs are reduced. In certain countries, you will have an outcomes-based revenue because you have the data. Performance-based metrics, so evidence. And a feedback loop, for me the most important thing, the feedback loop for continuous improvement. So, that's it. So thank you very much. And you're all here.